We're going to talk through how to use the normal tables. So the first thing we'll have to have a look at is the standard normal curve, which looks like this. So the standard normal distribution is what we call normally distributed data that has a mean 0 and a variance 1. The highest point of our curve occurs at the 0 mark on the x-axis because 0 is our mean value. If we keep looking at the x-axis, we'll see the values 1, 2 and 3 to the right of our mean value, and these represent the points 1, 2 and 3 standard deviations above the mean. If we look to the left of our 0 value on the x-axis, we'll see the values -1, -2 and -3, and these represent the points 1, 2 and 3 standard deviations below the mean. Probably one of the most important things to remember about the standard normal curve is that the total area under the curve is 1. One thing you might be asked to do is to find the area of a shaded region of the curve, and there are a few different ways that this might be asked. We could be given a diagram like this, where we're asked to find the area of the shaded red area to the right of our z value, which is 1.25. To do this, we'd have to go to the standard normal tables. So here we have the standard normal tables. You'll be given a set of these in your exams, and you can find them online or even in the back of most statistic books. So the first thing you'll see is the picture of the standard normal curve. This is telling us the values from the table will give us the area to the left of the z value, and they have the region shaded in to show you what they mean. If you're given tables in an exam, most of them will have this diagram at the top, so if you forget how to use them, always read that bit as it's really helpful. So if we move down a bit further, we can have a better look at the tables. In the top left-hand corner, we have the letter Z, and the top row and the first column are used to represent our Z value. In our case, our Z value is 1.25. We go down the first column, which is here, until we reach 1.2, which is here. So this is the row that we're interested in. So this value here is the area to the left of 1.20. This value here is the area to the left of 1.21. Our value is 1.25, so we keep going until we reach this value, which is here. So the area to the left of our z value of 1.25 is 0.8944. If we go back now to the diagram of our normal curve, we can fill in the information we know. We know that the standard normal tables gives us the area under the curve to the left of our z value. So we found out from the tables that this value was 0.8944, which I have filled in here. It's always a good idea to draw these curves out and to fill in any values you work out along the way. So we have the area of the blank region, and that's 0.8944, but that's not the area we're looking for. We know that the total area under the curve is 1. So to find the area of the shaded region, we subtract 0.8944 from 1 and we get 0.1056. So this is the area of our shaded region. Another case we might be given could look like this, where we're asked to find the area of the shaded regions. In the last case, we only had to work out the area of one shaded tail, but now we need to find the area of 2. So we just work with what we know. We know that the standard normal tables gives us the area to the left of our positive z-score. From the last example, we know that the area to the left of our z-score of 1.25 was 0.8944, which means that the area of our shaded region on the right is 0.1056. So to work out the total area of our shaded regions, we first have to have that our area to the left of 1.25 is 0.8944. Again, we remember that the area under the curve is 1. This means that the area to the right of our z value is 0.1056. But we're looking for the area of both shaded regions. Because the standard normal curve is symmetric, the area of the shaded region to the right of 1.25 is the same as the area of the shaded region to the left of minus 1.25. So to work out our answer, we just multiply 0.1056 by 2 and get 0.2112 as our area. Another way this problem could be given to us is like this, where we're asked to find the area of the center shaded region. So again, what do we know? We know that the standard normal tables gives us the area to the left of our z value. So the area to the left of 1.25 is 0.8944, and so the area of our unshaded tail is 0.1056. So to find the area of our shaded region, we have that the area to the left of 1.25 is 0.8944. Again, we remember that the total area under the curve is 1. The area of our unshaded right-hand tail is found by subtracting 0.8944 from 1 to give us 0.1056. Because the standard normal curve is symmetric, the area to the left of minus 1.25, which is our unshaded left-hand tail, is also 0.1056. So if our total area to the left of 1.25 is 0.8944, then the area of the shaded region is found by subtracting the area of the left-hand tail to give an answer of 0.7888. It could be the case that we're given the area of one tail and asked to find the z value. If you're given this kind of problem, always draw your curve out because it makes it a lot easier to make sense of. So we know that the tables gives us the area to the left of our z value, but we have no z value, so to work this out we have to work backwards. Again, we just look at what we know. We know that the total area under the curve is 1, and we know that the area of our shaded tail is 0.0166. So from this we can work out the area to the left of our z value by subtracting 0.0166 from 1 to get 0.9834. So in our previous example, we had our z-score and we used the tables to find the area to the left of it. Now we have the area to the left of our z-score, but we have no z-score. So what we do is we look within the table to find out what value of z corresponds to the area that is or close to 0.9834. So we're back to our standard normal tables with our z values along the top row and left-hand column, and our area values inside the table. So the last time we had our z-score and we used the tables to find the corresponding area. But this time we've got the area and no z-score. So we know that the area to the left of our missing z-score is 0.9834. So if we can find that value or a value close enough to it, we should be able to work out our z-score. So if we go inside the table, we can see that our first value is 0.5. We're looking for 0.9834, so we have to work our way down to the higher values. If we go along the side here, we can see that we have 0.96, 0.97, 0.98, so we're close enough to our value now. Here we have 0.9817 and 0.9857, so our value must be within this row here. So if we work our way across, we can see that we have 0.9834 here, which is the value we're looking for. If we work our way over to the side, we can see that we're in row 2.1, and up the top we're in column 0.03. This means that our missing z-score is 2.13. So it's not always going to be the case that we have our exact value in the table. If we have a value that is close enough to our given area, we use the z-score corresponding to that area. So if we go back to our original picture, we can see that the z-score that corresponds to a tail area of 0.0166 is 2.13. The development of these resources was supported by the NDLR and the Department of Mathematics and Statistics at NUI Maynooth, and they will be available from the following websites.